In example one, you were given this system of linear inequalities and were asked to determine which of these were solutions and which were not. So, looking at the system first, let's graph the solution or the feasible region for this. So you have 2x plus 5y is greater than or equal to negative 6. So if you solve this for y to put it in slope-intercept form, by subtracting 2x from both sides, dividing both sides by 5, you get y is greater than or equal to negative 2/5 x minus 6/5. Now again, the minus 6/5 might be a little bit difficult to graph it if you scale it like this. So you may want to choose like another point, like for instance, going back to this original, if you do 2 times negative 3, you'll get the negative 6. So negative 3, 0 is definitely going to be a point. And you can start it here and then go down to right 5, down to right 5. But you know what the line's going to look like. It's going to be a solid line. You're going to shade above it because of the greater than or equal to, and that's the region so far. 3x minus 4y is greater than or equal to negative 5. So again, putting this in slope-intercept form, mostly because you need to know what the inequality is. So if you need to know if you're going to eventually shade above or below the line. So for this one here, subtracting 3x from both sides, dividing both sides by a negative 4 now means you're going to have to switch this inequality sign around. And so you have y equals 3/4 x plus 5/4. And now again, the 5/4 part on this scaling might be a little bit tougher. You might want to figure out a combination that's going to give you the negative 5 over here. Like for instance, if x is 1 and y is 2, it's going to be 3 minus 8. And that's going to give you the minus 5. So 1, 2 is definitely a point, and then you could do your 3/4 slope from there. Solid line, you're going to shade below. The last ones are negative 4 is less than y, which is less than 2, which is the same thing as having y being greater than negative 4 and y being less than 2. These are going to be two horizontal lines. You want to be above this one and below this one. So you want to be above the negative 4 and below the 2. So you're talking about this right here. And as you can see, the overlapping region of where all three overlap each other is right here. So this would be your feasible region. Now that you have your feasible region, you can start deciding which of these are solutions or not. Is 3,1 a solution? Well, if you plot 3,1, it's right here. It falls right in that feasible region. It's a solution. 6,3. 6,3 falls right here. It doesn't fall in the feasible region. It's not a solution. Negative 4, negative 2 falls right here. Not in the feasible region. Not a solution. 5, 4. Also not in the feasible region. Not a solution. 6, negative 3. 6, negative 3 does fall in the feasible region. It's a solution. 8, negative 2. That falls in the feasible region as well. It's a solution. 2, negative 2. 2, negative 2 falls here. And as you can see, it's on the border, and it's a solid border. So this is part of the solution. And 8, 2. 8, 2 falls right here. It falls on a border as well, but it's a dash border. That dash border is not included as part of the solution. It doesn't make this one true at all. So it's not a solution. In the next problem, you're told that a Texas oil supplier ships at most 10,000 barrels of oil per week. Two distributors need oil. Southern Oil needs at least 2,000 barrels of oil per week, and Regional Oil needs at least 5,000 barrels of oil per week. You want to know which of the following are possible outcomes, select all that apply. And you have these various combinations. Now you can probably figure this out without doing a graph of linear inequalities, but it does make it a little easier to visualize if you do. So letting X be how much oil Southern Oil needs, and letting Y be how much Regional Oil needs. Southern Oil needing at least 2,000 barrels of oil per week means that they need 2,000 barrels or more. So that means that X is going to be greater than or equal to 2,000. Regional oil needing at least 5,000 barrels of oil per week means that they need 5,000 or more. So Y has to be greater than or equal to 5,000. In a Texas oil supplier shipping 10,000 barrels, well, they're only shipping to these two based off of what's being given. So the combination of what they supply to Southern Oil and what they supply to Regional Oil, the sum of these has to be at most, that means nothing more than this, but could be less, 10,000 barrels. So X plus Y should be less than or equal to 10,000. So if you graph this, now this is being set up where each one of these are in thousands. So this is 5,000, 10,000, 15,000. And so if you graph these, X being greater than or equal to 2,000 is right here, and you'd shade to the right. Y being greater than or equal to 5,000 would be a horizontal line here, and you'd shade above. This one doesn't take much to manipulate. I mean, if you just subtract X from both sides, it'll be in slope-intercept form, so you know you're shading below. But X plus Y equaling 10,000 is going to be this line right here, and you're going to shade below that. So your feasible region is this little triangle right here. And so when you're testing these out, giving 3,000 barrels to Southern Oil and 6,000 barrels to Regional Oil, that means that you have a coordinate on here of being 3, 6. And 3, 6 falls here. It's in the feasible region. That's a solution. That is possible. This is ordered pair 6, 6, which would fall out here. This is not possible. 4,000 to Southern Oil, 6,000 to Regional Oil. That's coordinates 4, 6, which falls right here on this border. That is possible. These are all solid borders, so that is possible. It's a possible outcome. The oil supplier provides 4,000 barrels of Southern and 5,000 barrels to Regional. That's going to be 4, 5. 4, 5 falls here. It's on the border again, but it's a solid border, so that is possible. 3,000 to Southern Oil and 3,000 to Regional Oil. That's going to put you right here. That doesn't satisfy these two at all, so it's not possible. And 5,000 to each one of them would fall right here at the intersection. And that is part of the feasible region, so that is a possible outcome. And so that is the end of this problem, as well as the end of this video. If you have any additional questions, please make sure to bring them up in class.